Okay, now I am recording. So, yeah, we're just gonna go through the questions, the practice exam questions that Sai gave us on a couple of days ago. I know that some of these don't have the answers because technically we're supposed to know the answers, so just make like your best guess. I'm just gonna be um launching like a poll to see like what your answers are, like what you think is the right answer. And then once the poll's done, maybe we can talk about it and like see like where people were, their thought processes were. So we can do this first one, the first one that's highlighted, uh, which says an unvaccinated child was playing outside and sustained a forehead laceration. 6 days later, he had episodes of crying, jaw clenching, involuntary upper extremity muscle spasms, followed by an arching of the neck and back, and generalized spasticity. I think that's how you say it. He received a diagnosis for tetanus. Which of the following best explains what is happening to his nervous system on a physiological level? So we're gonna do that question first, and then these are the answers. So just I'll give you guys like a minute to think about it, and then once once the minute's up, then I'll launch the poll. So it on the poll it says from A through D, but just pick however many um like A through C. So nobody clicked D. So I'll just give you guys like a minute to think about it and then I'll launch the poll.
Do you already know the answer?
No, these don't have like answers on them. So we're supposed to kind of figure it out. I think it says at the
Okay.
top, it says that there isn't
Yeah.
an answer key for it.
Some of them do in the
Oh,
beginning. Some of them are
okay.
highlighted.
Okay.
Yeah.
Well, I thought these would be a little bit better just because
Yeah.
it's
Okay.
like the answer's not really
Application.
there for us to see, so we would have to
Yeah.
figure it out. Okay, but I'll give you guys a minute just to think about it and then I'll launch the poll. Alrighty, I'm gonna end it right now and then we can see everyone's answers. So make sure you've gotten your questions in. I think everyone's answered. Oh, I can't answer. I just forgot about that because I made the questions, but um, I'll just show it right now. So I think mostly everybody answered. Um, so then here we are. Can you guys see the answers?
Yes.
Okay. So
I
it
was
looks
I
it
was
looks
between
like
A and C.
I'm sorry?
I was between A and C.
Okay. It looks like mostly everybody, well, most people chose C. Um, and then the following, so most people chose C, and then it was A, and then B. So I don't know if anyone who chose C wants to explain why they chose C, and then um, then we can do like A and then B. Oh, okay. It's okay, Andrea. But if anyone wants to share like why they chose C, please do. You can also just write it in the chat box if you cannot talk right now. Okay. Okay, well, I guess then in that case, nobody chose B. But Taylor and Drea, by any chance, like, what were you going to pick?
Now that I like look at the right section in the notes, I think it's C because he said affects inhibitory neurons in the CNS.
Mm-hmm.
That's what I would have chosen too. I was looking at the wrong section in the notes.
Okay, it's okay. But yeah, that's also what I chose too. So, I guess the answer is C.
So why C?
Because it mostly affects the central nervous system, which leads to that sort of like, oh my God, where are my notes?
So the tetanus toxin, it affects the central nervous, right? Not the PNS.
No,
Okay.
but also, I haven't, you know what, I thought I had those notes. Let me find them.
It's in his slides?
Yeah, it's in his slides. It's when he explains the disease itself.
Okay.
It is because it's on the actual slide of the tetanus toxin, and it pretty much inhibits the neurotransmitter release, which is what it says here. So it affects the inhibitory neurons, and those are important in sort of suppressing the neurons that lead to skeletal muscle activation, which makes sense because when you have tetanus, it leads to increased muscle contraction and then rigid paralysis, which is kind of the same thing as, not kind of, but it is upper extremity muscle spasms and arching of the neck and back, which is very similar to muscle contraction. So it's sort of, I don't know how to explain it other than it's staying in the position that it's supposed to be in, that it's not
Okay.
supposed to be in. So it's becoming very increasingly tighter.
Okay, thank you.
Yeah. And that's why they have the arching of the neck and back and stuff like that. Yeah. So, but that's good. Does everyone understand like why that is and like how it works?
This is from the very last lecture, right?
Yeah, this was the second to last lecture. So the last lecture we had was kind of him. We weren't going to use that for the exam. It was more him kind of explaining the bigger picture of everything, of like why we were learning about like action potential and like where they kind of fall in the body. So it was the second to last one.
Okay.
Um,
Okay.
okay, so let me go on to a different question. So
Wow, so many.
yeah, there's a lot of questions.
Yeah. There's a Quizlet review, and the professor said that it's very comprehensible. It's on the Discord.
Okay. I mean, we can go through that, but I think I want to go through these just because he
Okay.
did.
No, I'm just, yeah, I'm
Oh yeah.
just,
Yeah, no, it's okay. We'll go through this one first. So, and then we can go to that one afterwards. So I highlighted a different question, and I'll give you guys like a minute to think about it. It says, in a normal neuron, which is true? A, the axon helix has more negative threshold, making it closer to resting potential. B, the axon helix has more positive threshold, making it closer to resting potential. C, the cell body and the axon hillock are neutral until ions exchange occurs. Or D, the entire neuron is naturally negative. So I'll give you guys like a minute, and then after the minute, I'll launch the poll again. So yeah. Okay, I'm gonna launch the poll again. So be sure to keep an eye out on that. Okay, so I just opened up the poll. And whenever you're ready, be sure to answer the question. Okay, so I'm sharing the results now. Can everybody see them? Good. It looks like most people chose A. Does anybody wanna? Oh, cool. Cool. Maybe Stephanie, you might want to explain to us like why it is A. You can type it out also if you want
No,
to.
it was in the book. It just says that the axon is naturally more negative. I really can't explain why, like the mechanism behind it, but it made sense because let's see, the axon has more negative threshold, making it closer to resting potential. I think it just has to do with that's where the ions do come in through. They come in and out of. So it would make sense that when it's not being when it's not having a positive charge through ions coming in, like I think it's normally just has a lot more larger amount of negative ions. I don't know if that it doesn't really make sense, but it was in the book.
Okay.
Is
Okay.
it on the slides?
It's just thought because since it says the resting potential and like isn't resting potential -70, so I'm like, okay, well, I guess it has to be in the negative threshold.
Yeah.
But I'm not sure why.
Is this question on the slides or just the book?
It was in the book.
Oh, so is the exam based on the slides and the book also, or just the slides, or the book and the slides?
He did recommend we do read the book, so I'm assuming like it would be a good idea just to have better background information on it.
Oh, okay.
Yeah, no, but that makes sense. Now that I'm thinking about it more clearly, it does make sense for the axon hillock to just normally have more negative threshold, as it's kind of still at that almost resting potential. But all right. But does anyone have any other questions, or like, does anyone need a clarification? Just making sure. But thank you, Stephanie, for that question, for writing it. I hope you got your extra credit. So let me choose a different question. I'm just gonna just kind of choose whatever. Okay. Let's do this one. Let's do number 63. It says, Stephen has been running for over 45 minutes in an enclosed room and notices that it's hard for him to breathe. A VO2 max level has been tested for and shows that his oxygen levels are dangerously low, resulting in little to no ATP production. What would be a potential result of the severely decreased amount of ATP? So A, the sodium potassium pump will be unable to maintain the internal concentration of potassium to sodium ions in the cell. B, Stephen will develop I don't know how to say that, rhabdomyolysis from running with a severely decreased level of O2 in his body. The membrane separating potassium and sodium ions will completely disappear, or D, none of the above. So I'll give you all like a quick minute, 30 seconds to a minute to think about it, and then I'll pull up the poll. Alrighty, I'm going to end the poll, and these are the results. So the answer is A, the sodium potassium pump will be unable to maintain the internal concentration of potassium to sodium ions in the cell. Does anyone want to like explain why they got A, or what like your thought process was behind to choosing A as an answer? You can turn on your mic or write it out.
I honestly I wasn't sure if A was correct, even though I chose it, but I just chose it because it seemed the most relevant to what we've been talking about.
Yeah, that's what I thought too. So Corn says, I'm sorry if I said your name wrong, by the way. It says that no oxygen means decrease in ATP production, which does make sense. I think it's pretty straightforward. If there isn't oxygen in general, then that means that it would just have a really hard time maintaining that sort of homeostasis. But does anyone have any questions?
What does it mean for part A when it says it's unable to maintain that internal concentration? Does that just mean like inside the ATP system?
I think I missed the last part of what you said.
Like where it says on part A, 'cause I know part A is the answer or answer A, and it says unable to maintain that internal concentration. So that just means like within the body, internal concentration.
Yeah, I would think so, because if it's not able to maintain the internal like concentration, then there isn't enough in order to have that ATP production. And like Corn said, where there's no oxygen, that just means that there's decrease in ATP production, and that essentially it converts. Actually, I don't know if you want to write it out, you can write it out, but what do you mean by converts ATP to ADP?
Oh, sorry. It's because in the membrane it has the sodium potassium pumps.
Mm-hmm.
And then so in order for those pumps to function, it uses energy, and that energy is ATP. So when it uses it uses a phosphate group.
Mm-hmm.
So it turns into adenosine triphosphate to adenosine diphosphate, right?
Yeah.
So if you're not breathing in that oxygen, there's a decrease in ATP production. Like in like basic terms, if you're not like breathing,
Mm-hmm.
then you're not able to get that ATP. And then if you don't have ATP, then it'll slow down the sodium potassium pump.
Okay.
So wait, it just inactivates it and not makes it disappear, or like quote unquote kills it, right? Am I understanding it like that?
Wait, isn't that function already states that there's no oxygen? Yeah, that's why. So it states that there's no oxygen. So if you don't have oxygen, then how are you going to make more ATP? So yeah, it directly affects the sodium potassium pump.
Okay, yeah, because I picked A, but I was also thinking it would be C, that it would just completely disappear. But then I started thinking maybe it's just inactive and it won't actually kill them. So that's why it makes sense that you're saying that. Thank you.
Yeah, I didn't pick C because like if it completely disappears, like the way I interpret that is kind of like denaturing the membrane. So like if there's just lack of decreased amount of ATP, then it's kind of like slowing something down, like in my thought process.
Okay, I get it. That makes sense. Thank you.
Thank you for that explanation. Very well done. So I'm going to, I guess, just choose another question. I think I'll do maybe like a couple more questions so that we could do the case study afterwards. So if I don't stop at 8:45, somebody stop me, please. So at 8:45, we'll do the case study. And if anyone was in class today for his Monday class, that will be your time to shine. But right now, let's do a couple more questions, and then at 8:45, we can do the case study. So let's do some that are up at the top. Okay, let's just ignore the fact that some of these questions are already highlighted for the right answer. So just pick whatever you want. So we'll do this one. Number 3. When the cell membrane undergoes a voltage change from negative 70 MV to positive 30 MV, what is happening on a molecular level? So I'll give you guys all like 30 seconds to a minute, and then we can discuss.
Well, the answer is already highlighted. No?
Yeah, but like think about it a little, like why would it be at least like kind of, even though the answer's already there, give your best guess and kind of explain why it would be that answer.
Okay.
Or if the answer is already highlighted, maybe we can just discuss why it's D.
You know what? That's a good idea. Okay. Well, we'll just, does anybody want to explain why it is D?
Okay, so negative 70 is the resting, right? So then, and then 30 is where the peak of the action potential. So then that period is when the sodium channels are open. And then from negative 70 to threshold, that's when like the depolarization starts happening. So then after it reaches threshold, then the sodium channels like open completely. Right.
Yeah, that makes sense. Is everybody on the same page as to why that is? If you aren't, please let me know. Please ask if you don't understand that. But if everyone is on the same page, then I guess we can go to a different question. So I will go to a different question. So let's see. Okay, let's do one of these ones. Let's do this one. The autonomic nervous system has two divisions, sympathetic and parasympathetic. Which of the following regarding sympathetic is correct? Okay, so this one does not have the question highlighted, so
Oh wow. Is that a one word?
no, I think it's just a typo. So
Oh.
there aren't any spaces on here.
Oh,
It's just a typo, so that it's all like one sentence.
okay.
Okay. Okay, I'm gonna end it because I also kind of thought the same thing. These are the answers that we have so far. So it's 50-50. I don't know if anybody wants to explain that one. I also kind of thought it was E. That like they'd be both correct. But if anyone who got B can explain like why they got B, please do. Let me just edit something really quickly, but if anybody wants to explain like why they got their answer, please feel free to write it in the chat, or you could talk out loud.
I was just looking at the notes, and then sympathetic falls under autonomic, which falls under efferent.
Yeah. No, yeah, that makes sense. Anybody else? If they want to answer, please feel free to answer. Or if anyone's confused on why that is, please let me know. But let me do something really quickly. Does anybody want to be a co-host for just a quick second while I make a new poll? I can make you a co-host and you can just continue on with just like choosing random questions. If nobody wants to, then I'll just do a different question and then you could type your answer in the chat. Here, let's do this one, 37. So, oops, my bad. Which ion has a direct effect on the interaction of synaptotamines and snare proteins? So it's either A, B, C, D, E. I think this is all one question. It looks like it looked like it was two, but I think it's just one. So this is all one question. So I'll give you guys a quick little minute to think about it while I fix the poll really quickly. There we go. I got it. Okay. So answer the question. I'll give you guys like a quick couple seconds and then we could talk about it. Sorry, I was talking and I didn't even realize I was muted. My bad. Can everybody see the answer to the poll? Okay. Does anybody want to explain why they got letter B? You can type it out in the chat too if you'd like, or say it out loud. Doesn't matter.
CA2+ is just the one we've been seeing a lot of in the like the drawings and stuff.
Mm-hmm.
And then it wouldn't be C because that's not the correct way to write calcium.
Yeah. Yeah.
Yeah, because calcium has a 2+ charge.
Mm-hmm. Makes sense. Okay. So I think I don't know if you guys want to like keep going with these questions. Let's do like one more. We still have a little bit of time before 8:45, so let's do one more. Okay, let's do this one. So in simplest terms, how many? 1, 2, 3. Okay, so this is also an A through E type of question. So in simplest terms, how does neuron communication work? And I will give you all a quick second or two to think about it. I'm just gonna launch the poll, but you don't really have to answer it right away, but I'll give you guys like a minute or so to answer it. Alrighty. So it looks like everybody mostly picked A, which is also what I thought of. And it looks, does anybody want to do any more? Just to make sure that in case you all want to do more, we can do more, but I thought it'd be also really helpful to look at the case study, because I know that some of you are here from his Monday class, and well, I have class tomorrow, so I also had questions as to like what it's going to be about or like how it went. So if anybody still wants to do more questions, I don't mind, but also if you guys just want to do the case study, we can do that too.
For the case study, he went over it in detail in class today, and he makes sure that everyone gets 100 on the quiz, so you guys don't need to worry like too much about it, but we can still like go over it.
Okay.
He gives you unlimited tries too.
Oh, okay. I didn't know that. That's cool.
He only tells people who's in class, so so that anyone who like doesn't show up kind of like misses out.
Okay.
Well, that's why in the email he was like, be there or be sorry.
Yeah, I was like, ooh, harsh.
Okay, well, that's good to know. Actually, let's take a look at it.
But I would definitely, yeah, I would come prepared with like your answers ready, so that like you can like discuss it with other people.
Okay. So we don't have to have any like questions on it, like just kind of have like background knowledge on the case study.
I mean, like he reads it with you guys and you guys go over it and highlight like the important stuff, and then he'll go over each question with you.
Oh, okay. But most of the questions he'll kind of go over and then we talk about it in class.
Yeah, he'll make sure you know the answer to for each question.
Oh, okay.
Did
Yeah.
you go over the case study before coming in on Monday?
I read it this morning before class and kind of gathered my answers and like wrote it down on a piece of note paper. So I felt like more prepared, but you would be totally fine if you didn't come prepared too.
Mhm.
Okay, but we don't have to do, I mean, not that it doesn't hurt, but we don't really have to annotate or like think of sort of questions on the case study itself.
No, and when you input the answers, it's not like you don't have to explain why you got it. It's just multiple choice.
Oh,
Yeah.
oh, fun. Okay. Wow, that's pretty quick. I mean,
I
what
felt
did you guys
understood.
think about it? Sorry.
Oh, you're good. Sorry.
Oh no, I was just gonna say, like, what did you guys think about like the case study, like when you read it and stuff? Like, was it hard or um easier to understand?
I felt like I understood it for the most part. It was only like question 9, I think, that I was kind of stuck on. But I mean, we went over everything in class.
Oh, okay.
So this should represent what's on the exam or something like this.
I think so. I think I remember him saying, if you feel confident, like with the case study, then you should be fine on the exam. I'm pretty sure I remember him saying that.
Yeah,
Okay.
he said that at our last class too. He said if you felt comfortable on the case study and the practice exam questions, that you should be more than prepared for the exam.
Did
But
we go over the questions from last week? There was the last slide from last week,
oh,
the last Thursday, Wednesday. Did he answer all
The
those
other case study?
questions? Yeah, there was a question, a couple of questions.
oh,
I just didn't get the answer for a lot of these questions.
You're talking about the one we turned in on Canvas, right?
Yeah.
No, Vanessa, I don't think we went over that today, right?
I think he's talking about the questions at the end of the slide for last week.
Yeah.
Yeah.
Yeah, we went over all of them and we had to turn it in like before the class ended.
Okay.
But not today, right? Like, I think he means after they turned it in.
He's talking about the one from last week on Wednesday, I think.
Oh, okay.
Does anyone have the answer for it?
I think I do. Let me check.
Because I'm not sure if I'm getting it right, so I just wanted to check.
All I really have answers for are for question 7 and 8. The other ones are kind of
Oh, that's what I have too. I was wondering
Oh,
about the
okay.
other one.
Okay, no.
I don't have the answers, but if you pull up the slide, then I think I can refresh my memory.
Alrighty, let me do that. It was this
Yeah,
one.
it was. Yeah.
This one. Slide
Yeah,
show.
it's this one. So it's the one in black, the one that tetanus toxin destroys snare.
Oh, that one is. It would be increased muscle contraction and rigid paralysis.
Oh, okay.
Yeah, because of the inhibiting. So the snare proteins. So the tetanus toxin. I mean, it's kind of like self-explanatory. So because of the fact that the tetanus toxin destroys the snare proteins and it inhibits the muscle contraction, the direct result, or at least the direct physical result that you'll get, is increased muscle contraction and rigid paralysis.
And so for the second question, do the psychotic neurons have large or small X in diameter? Is the answer on the slides?
No, the answers aren't on the slides.
No?
No.
This one is kind of like just like applying the stuff we learned in class. So like you need long axons for faster communication, right? Like obviously longer axons would communicate faster than short because the signals would be like closer to each other. So then the answer would be large axon
okay.
diameter. And then in order for the signals to move quickly, you have to have them myelinated. So they would be highly myelinated.
Oh yeah, it just makes sense.
Yeah.
And how does this affect the action potential? So it would just be normal, right? It wouldn't, if it's large, then the action potential would be
It would be
big.
quicker
Yeah.
because the signals would be quicker.
Yeah, okay, makes sense. And the last one, cocaine is a drug. When doping. Okay, describe the molecular effect of cocaine on the synapse. Okay. So on the molecular level, well, I see the answer is in the question, but
I kind of forgot what he said for this one. Does anyone else remember?
Is it related to that picture that he went over from like the synaptic cleft and that picture that we're supposed to know the diagram, like the sixth? I think that relates to it maybe. Yeah, I think it relates to that diagram where we have the presynaptic and the cleft.
Yes, it is. But it's a specific one. It's after. Let me see. It's this one. So that's kind of referring to this synaptic transmission.
Okay.
Let me look back at the question and see what it says.
Oh, okay. And he told us to focus on, I think it was A. Oh, let me see.
Yeah, he said to focus on A, B, C, E, and G.
Okay, so the answer would be, so that would be the molecular level. That's what's happening. But it's one of them. It's one of those options. Or maybe combination of them.
So cocaine blocks this. I think it's this one. Cocaine blocks the transmitter reuptake, which then presynaptic membrane. Which I guess then would mean, would that mean that none of this happens if it's blocking this right here on E?
I'm not sure.
Okay, what the question was like, what would happen if the reuptake didn't happen, right?
Yeah, so the question says, when dopamine binds with postsynaptic receptors, the user feels euphoria and excitement. Cocaine blocks dopamine reuptake protein transporters in the presynaptic membrane. Describe the molecular effects of cocaine on the synapse. So it's
Wait, what does reuptake do again?
Reuptake, I think that means uptake. I don't know. Like I just reuptake. So it's reuptaking it.
Yeah, but what's the effect of the neurotransmitters going back up into the presynaptic cell? I don't think I never really understood the reuptake part.
Because I see the two arrows on the picture where it says reuptake and there's two arrows. Maybe it's going, I don't know, but maybe it's going back and forth. That's what I'm getting from this reuptake. That it was here, then it's there. Like it was like a circle thing, like from one place to another.
I found the slides that talks about reuptake. It says, actually, let me show you all. Of Here we go. Here it is. So it says to terminate the signal actively transported back into the presynaptic.
I think it's because like not all of the neurotransmitters go to the receptors. So it kind of goes back into the presynaptic cell. So if you're on cocaine, then like it stays in the cleft longer. So the neurotransmitters are all like they're binding to the drug, and it's like using up all of them. So it's like not recycled or something like that. Like it can't be used again by the cell.
Oh, so then the neurotransmitters bind to the drug?
I don't know.
I mean, I think what you said makes sense, like beats my explanation.
Makes sense.
Yeah, I think it does. It does bind to the drug because then that would mean that it would what's the word? It would take a lot longer for it to sort of go.
Oh, is it because like when the neurotransmitters reuptake into the presynaptic cell, then it like comes back out later to try to bind to the receptors again?
Yeah, I think so. And then if
Yeah.
they're on drugs, then all of those neurotransmitters like are being used. So
Oh, okay.
I can't do the reuptake and like use them again.
Okay.
Yeah, that definitely makes a lot more sense in my head. Thank you for that. But I don't know if you guys have any other questions on any of these ones, or any like last minute questions, because I know that it's already 9 and I don't want to cut into people's times. So if you guys have any last minute questions, please feel free to ask away.
A quick question for the range for the last question. It's 30. Is it 30? The range?
Yeah, it was positive 30.
And that's it, just one number?
Yeah, it was just, yeah.
He was kind of tricking us with that.
Um, do you know why 30?
Because that's the peak of the action potential.
Oh, okay.
That's when it's completely permeable to sodium ion. Like that's when the sodium channels are completely open.
So that's when the action potential it's at its peak?
Yeah. And then
Okay.
because the question where it says some permeability to potassium, that's why it doesn't go past 30.
Oh, okay. But it goes to 60, right? Because it can go to 60, no?
It shoots towards 60, but because of the potassium, it stops at 30 and then it goes back down.
Oh, okay. And when it's negative 70, there's no action potential, right?
No, that's resting.
Okay.
Alrighty. Any other last minute questions or comments that anyone might have? If not, oh, actually, Vanessa, what do you mean? Don't forget the picture.
For the extra credit, maybe.
Oh, is there a picture that we gotta do?
No, like the screenshot.
Oh, yeah, that's right. I was gonna do that right now. Okay, so I will stop it. I'll stop the recording right here and I will take, actually, no, that's a lie. I will not do that. Let me do this. So you all know that I did it, so, and I don't forget. Oh my God, where is it? Oh, here it is. Okay. So this is everybody, right? Okay. These are all the, oh wait, oops. 1 second. Oh no. No. Okay. There we go. Okay, cool. So I think I took a picture of it and I'm gonna save it. Okay. And we are good to go. I got everyone's picture in it.
Good
And
luck on the exam.
I know, thank you all for coming. Good luck to you all. And I hope you all have a nice night.
There are more study groups tomorrow and Wednesday.
Yeah, there's also, yeah, if you all need another study group, you can all go to one tomorrow. I think there's 2 tomorrow, so you can go to that one. But have a nice night, everyone. Goodbye.